we interrupt this program to bring you...
And I started looking into different topics, and one of them was behavioral cloning, which is like you record yourself playing the game and what actions you input, and then you have a neural network which learns from your examples and then try to generalize. Maybe there are two directions in which we can go. There's one, how the network learns, and then there's what are the downsides of training a network in this way. There are many ways in which you can train it. There's like supervised learning where you give it examples and then it learns from your examples. You have genetic algorithms, which is not quite machine learning. It's like you have a population and it randomly behaves, and then you just keep those that behave better. It's like random search, but a bit more smart. And then there's reinforcement learning, when you just let an AI try different things and then it will try to learn based on a reward you give.
Isn't supervised learning supposed to be like you give him the perfect run?
In supervised learning, what you want to do is have an expert, someone who already knows how to solve a problem, and then it just learns from you. Actually, what we can do is like have a short demo of how it works and then try to explain what's the pros and cons. So right now I have already some recordings of the game, but what I want to do is like delete everything and then explaining why it works like this. If I were to start the game, then I'll have this, and then I just have to press the keys which make the actual car drive, and I have to do this like several times. The good part of using such small games for environments is that you can actually go into the RAM of the game and then read different values. I already exposed what's your position on the track, what's your actual speed, so stuff that you cannot see in the image, but the game knows about, and maybe you can then use them. I'll do something stupid right now because I want to prove a point. So if I were to cut the road, because I feel like it's faster this way, and there's another place where we can do that, I think around here, yeah. So if you cut the road, then it will learn to cut the road. The disadvantage of this would be that it may always cut the road, even though it's not the best action to do in that scenario. The way it trains is that after I played a bit, I'll have the game recorded with everything that I did, and these are all the keys that I pressed. And how it trains is that you have this frame, and then the frame is composed out of pixels. So if you were to look at it, let's say it's a smaller picture, let's say this 1, 2, 3, 4, 12 pixels. And then what you do is you give these pixels to a network. And at the end, you want it to predict what's the key that you press. And let's say the keys that I can press are up, down, left, right. And it has to predict that for this frame, it should press up.
Isn't it supposed to always press up if it's
Uh,
the perfect run?
there are some turns where if you press up all the time, then you'll drift out of it. Or you can press a combination of buttons. So let's say if you have several combination of buttons, how you would tackle it. If you have up, up, left, up, right, or do nothing, then we consider this the possible outputs, which means that this will be 0, no, 1, 0, 0, 0. This will be 0, 1, 0, 0, and so on. It's like if we have to press a button combination, then what we do is that we get all those button combinations and we consider them separate outputs. So the bad part is that if we have a big input, then that means we have a big network, and the bigger the network, the slower it trains. So what we want to do is to do some processing of the input, and that means doing stuff like, okay, so I don't know how well you can see it, but we took what's most important in the image and we scale it down, and this is like 28 by 28. So rather than having something like 200 by 200, which in total will be something like 4000 pixels, we scale it down to 28 by 28, and that's something like 700 something pixels, which makes it easier for the network to learn, and then it will generalize faster. You have so much redundant information that you don't use. Why not make the job easier for you to train? I try to scale them up so you can see them better. So it's something like this. You have this image and then you just crop the part with the road, and then you resize it such that it still makes sense for us. We can still navigate through this environment, and it's easier if you give it lesser inputs so it learns faster from the examples.
Can you show us right now how he learns?
So first I have to process the recordings, because I showed you we have to crop that inner part and then rescale it to reduce the dimensions that it has to learn from. And then we can do a training phase right now. What it does, it looks at the images, it knows which keys it should press, and then it tries to predict, okay, for this frame I should have pressed this key, for this frame I should have pressed this key. And then I say, okay, you did good or you did bad or you were very close to it, and based on how close it was, it gets penalized less. And you have this decreasing error, and you do it for several iterations until you see that the error either stagnates or starts to rise, in which case it means that it starts learning stuff by heart. So this is from the recording that short gameplay that I had with you guys in the call. It's only using the short gameplay that I did with you guys, and yeah, it broke already. What happens is that if you don't give it enough examples, it will get into situations that it didn't see before, like it. For instance, I never showed it what to do when going off track here or going into some obstacle, and that's the downside sort of so here it got in an obstacle and then it crashed, and it didn't know like it should have go backward and then go to the right because I didn't give it examples with this. So that's the downside of having it trained via supervised learning, because it only knows what to do based on the examples that you already gave it. If it goes in a new environment, what it does is it tries to approximate what's the best behavior. But I never showed it that it's okay to go backwards. So it doesn't know it's okay to go backwards. So what I'm doing now is I'm merging all the recordings, the one that I recorded with you guys and the other two that I had previously. So we'll have more training data.
The network will never behave better than you, right? In best case, it will do just as good as you did in your recordings.
Yep. It also depends on like how consistent you are. Like, let's say in the first run, in the first recording that I do, I want to go straight only on the center of the road. And then on the next recording that I do, I want to go off road, like cut as much as possible. Then the network most probably will do something like an average between them. So it won't be 100% like you, it will be like an average of all your behaviors.
And theoretically, if you only give it only one run, it might learn to do just exactly what you did.
If you give it too few information, it won't learn how to generalize. So now I added a few the other two recordings, and it seems like it behaves a bit better. It even drifts a bit. It's like what you said with it shouldn't be okay to always accelerate, and it depends. In the other two recordings, what I did is that I didn't accelerate all the time.
But it looks like it's also risky to give it too much information, right? Maybe in one frame, like in the exact frame, since you were doing 100 random runs,
Mhm.
maybe in the same frame you were doing left and in another scenario right, and then, they were.
Ah, okay, right. So if you have exactly the same frame with different inputs, it depends a lot on the order that the frames got to the network. Because the way it learns is it gets to see all the frames, but it sees them in batches of X. I think I put 32. So it's like I look at 32 recordings, frames, and key presses, and then what I do is like I try to learn from the average of all my errors. Like in those 32 scenarios, I was the worst when having to turn right. Then I'll start turning more right. And then in the other 32 frames, I saw that I have difficulties when accelerating forward. So I start accelerating forward. If it's very random, then it will do random stuff. You know the normal distribution, then you'll do just the average and you'll be in the middle of the bell curve. If you're way too random, then you'll be all over the place.
Follow-up question from this.
Mm-hmm.
Let's say you give him like 100 corners that you take,
Mm-hmm.
and in 50 of them you go right, in 50 of them you go left.
Mm-hmm.
If you train it 2 times, will it always choose left?
So I said at the beginning that you have some values in the neurons, right? So those values are randomly initialized. It's like having two children, perfect twins, have the same structure, but have different wirings in their head. So if you can 100% have the same person, then you have 100% the same output. But if the wiring is just one bit different, then it won't produce exactly the same output.
Okay, so you're telling me that if you do that, you're training, let's say, 5 times. Okay.
Depends a lot on how you randomly initialize the network. You can either force it to behave the same way on the same data, or you can have different variations using the same data.
I have a question. So
Yep.
you've been saying that you're saving your own input and the RAM from the game, the metadata.
Yep.
Are you also using that in the training, or is it just the image?
It's just the image for now. Ideally would be for us to also add the speed of the cart. There's this scenario that I trained. What happens is that the network doesn't have any temporal information. It only lives in the moment. It only sees this frame and then acts based on it. It doesn't have any prior information. Because of that, it cannot estimate like what's your speed. If it gets to a point, yeah, like here. Here it has zero acceleration because it went outside of the driving area. So right now it has speed of 0. But in my examples, I wasn't pressing any key here because I just let it go with inertia. And since it doesn't have any information about its current speed, it got stuck here. And the only way it got unstuck is by Princess Peach or someone else who kicked him in the butt, like here, and then it knew what to do because it was in a different position where I started pressing keys. So that's exactly the limitation of supervised.
Okay, so you should like always press keys, no matter where
Either
you are.
always press keys, either give it more information, like give it speed information, uh, other information that we as humans can perceive, because we're not like looking at just one frame and deciding based on that specific frame. We are looking like a series of frames, deducing like what's the speed that I actually have. Is it okay to accelerate or whatever?
One more question:
Yep.
how far are you going with this?
That's it. My purpose was to train the network, which is capable of finishing Mario Kart like at least one lap, and it can be extended a lot. This was like a very dumbed down version of how you can build a bot, such that maybe other people can chime in and like look at the code, play with different parameters, and try to maybe understand like how it works and maybe ask questions on Discord if needed. So yeah, that was the point of this.
What do you think would be the best kind of learning for this specific case for your Mario Kart?
It depends. So if you would have the same track all the times, then supervised learning would be enough because it's easier. If you have different tracks with different environments, like you want to have an AI which is good also on, I don't know, Rainbow Road or others, then it's better if you do something like reinforcement learning.
I have a weird unrelated question. So let's say you want to do something similar for a bigger game
Hmm.
that maybe you don't really have access to metadata
Hmm.
from the RAM
Hmm.
directly. How would you approach that?
If you don't have metadata, then it means that the only thing you can work with are the frames. Like if you were to make a bot which knows how to pilot a car in GTA, That it means you only have access to the frames. There is a stupid rule that I tend to agree with more and more. It's called no free lunch, and it applies to software development in general. It's like never skip the solutions which may seem dumb or easy just because the more complicated solutions may seem fun. So rather than going with something very complicated at the beginning, I would go something like first I would decide on what's the end goal. Do we want to finish the race at all? Do we want to finish it on the first place? Do we want to finish it while driving backwards? Stuff like that. So we first have to decide like what's the goal, and then try to create an MVP, the dumbest thing we can get with one very simple approach. Then we get to its limitations, see how good it behaves. If it doesn't behave good, I'll switch to the next best thing like CNNs, and then iteratively go on like this and try to see what's the next best thing I can do without making it too complicated. So that's my approach, because initially what I did when trying to learn machine learning is that I always look at what's the state of the art, what's the next big thing that everybody hypes, and took the most complicated and over-engineered solution possible, and then spend a lot of time initially understanding it, then plug it into the system and making it work fast enough. Because usually state of the art is also heavy and you cannot train it as fast as I did this. For some networks, you have to leave them like days or weeks to train and then see that it's not good enough. Okay, so that was my TED Talk. Thank you for coming, and hope it helped you somehow.